So I think this is page 4 in your packet. And so this is our first day of the AP review. This is one variable data. So the main things that we're going to talk about, they're kind of listed over there on the left-hand side, but we're just going to first go through those. The first one is remembering some of the vocabulary for shape. And besides being unimodal, and unimodal means one mode, and bimodal, besides the modes, what are some other vocabulary words of shapes? Good. Symmetric. So this would be symmetric, unimodal and symmetric. Okay, how about this one right here where it's almost the same across? Uniform. Very good. That is a common one that we miss, calling it uniform. Now how about this one down here? Is this skewed, but is it skewed left or skewed right? It is skewed left. Skewed left, tail left. So this one is skewed left. Okay? Now, we're also going to be talking in a moment about how the shape changes the relationship of the mean and the median and the mode. All right. But here's a dot plot. You remember you put those dots where they go. We've seen that. You've done those recently whenever we had to do the conditions for linear regressions. Now, let's talk stem and leaf plot. Remember, you've got your stem and then you've got your leaves, and your leaves are going in order from least to greatest. Don't forget that you need to, if you draw this on your own, include a key and include the units. If this was talking about number of shoes, then you would want to include those units. Now, here is a back-to-back stem plot, and it does not have a key with it. So I want us to practice doing that key right now. So this is about the value of quiz 1 and the value of quiz 2. So let's say we have the information that goes like this. Let's do the number 1, 3, and 4. So what I want to know is, what does this mean that the value of quiz 1 and quiz 2 are? What's the value of quiz 1? Good. You need to read from the stem. Quiz 1 is 31. It is not 13. So quiz 1 is 31 and quiz 2 is 34. Okay? So just sure that you are reading from the stem out. Okay, moving on. So now we have a bar graph versus a histogram. And I wanted to make sure that you knew the difference between what those looked like and what kind of data those contained. So first of all, our bar graph contains categorical data. Categorical. So it's put into categories. For example, if this was a test, maybe this looks like your answer choices, A, B, C, D, E, maybe the number of questions that had those answers. So you could see as a teacher if I favor C as the answer choice, Now what do you notice pictorially the difference between the bar graph and this histogram? What stands out to the difference between those two? Okay, good. This bar graph has got spaces in between the categories. And there's a reason for that. There are spaces there in between the categories because it's not a continuous numerical value. See, our histograms are numerical or quantitative. That's also the common word for that. So these are quantities. This is a number line down here at the bottom. So this is continuous values getting higher from left to right. So there are no spaces because it's continuous quantities of values. Okay? So the category are separate because I can move those in any order I want. Alright, so that's the difference between your bar graph versus your histogram. Now we're going to move into talking about measures of center and spread. So measures of center are things such as your mean, median, and mode. Now there's a couple of things that I wanted to add to this. And first of all, I want to talk about how shape of the distribution affects your measure of center and spread. Okay? You can see, I have some pictures here. You can see from this picture that if it is symmetrical, what can you say about the values of the mean, median, and mode? They're the same. But if we have got skew, whether it's skewed to the left or skewed to the right, those numbers are not the same anymore. They have been affected. And which measure would you say has been most affected by the skew? Good. The mean is the statistic that has been most affected by the skew. So we're going to write that here. Mean is affected by skew and outliers. And we have a song for that later that we'll do stuff on. But I want to talk about another thing called resistance to the skew and outliers. Which measure is most resistant to skew and resistant to outliers so that it doesn't, what do you think it means to be resistant? It doesn't change. It's not affected by it. You know, if you're water resistant, then you're not getting affected by the water. So which measure would we consider to be most more resistant to that? Between mean and median, because we kind of mode really, I don't know what we do with that. We're going to talk about median is because that's the one that typically goes with the IQR. You know, the measure of center that goes with a certain spread we use. So we're going to talk about how we're going to note that the median is resistant to skew and outliers. Okay? So we want to remember that. If you have skew, if you have outliers, you want to use median and IQR. So that takes us to, one other thing I wanted to point out. What is the relationship? If I have skew to the left, what can you say about the mean? It is less than the median. And if I have skew to the right, what can you say about the mean? It is greater than. So the mean is pulled in the direction of the skew, but I have another way to remember this. And let's see. I don't know if I have a good space to do that. Let's put it here. Mean. Let's write these in alphabetical order. Mean, median, mode. All right. So mean, median, and mode. So what I want to tell you is if you have skewed left, I want you to point your inequalities to the left, and that will tell you the relationship of their values. So if it's skewed left, the mean is a smaller number than the median, which is a smaller number than the mode. And I could do those the other way. So I could say, if it's skewed right, then look, I'm going to draw my inequalities to the right. Okay, so then I can say the mean is a greater number than the median and is greater than the mode. Okay, so suppose you have been given 10 numbers and you found that the mean of those numbers is 73 and that the median of those numbers is 78, and you are then asked what is the shape of that distribution, what can you say about its shape? It is skewed to the left because the mean is less than the median. Okay, so from numbers you can determine its shape, that the mean is less than the median, so it's skewed left. Okay, so that's how you can use that information. All right, moving on. Measures of spread. Range is, the highest minus the lowest. We don't use that too much because it's got a lot of, it can change, it's very limited in its use. It can change a whole lot based on if you have outliers and such. So it's just really actually not too useful. We typically use, this is supposed to be IQR, not IRQ. So IQR, which is your Q3 minus Q1. And this is good because it is more stable, less influenced by extreme values. Since it is more stable and less influenced by extreme values, we say that this is more what? It is more resistant to skew and resistant to outliers. So if you have skew, then you must choose to use median and IQR. Ooh. Symmetry, use standard deviation and mean. Okay, our standard deviation is a more complete measure of spread. It's that average distance. You know, we've used that a lot. It is most frequently used. So we want to use this if we have symmetry, because this is also affected by skew and outliers. All right, moving on. But over here to the side, I've got pictures of our box plot. Okay, so let's recall how to do those. What are the values in the 5-number summary? Minimum. What else? Q1, which is your first quartile. Median. What else? Q3. And finally, the max. Okay, so those are the 5 numbers in a 5-number summary. So if they tell you, here's the 5-number summary, they're giving you those in order. Min, Q1, median, Q3, and max. One thing that I didn't list on here, which I need to add to these notes, is how to get the fences, the outlier fences. So the outliers are based off of how far you are away from the box. Do you remember how to get an upper fence? Let's write these notes in here. Upper fence. How do you compute an upper fence? Perfect. Excellent. Very good. Okay, so you take the upper part of the box, Q3, and add 1.5 IQRs for the upper fence. For the lower fence, we got Q1 minus 1.5 IQRs. And we'll sing a song later to remind you of that. Okay? Q1 minus 1.5 IQRs. So when you put those fences on, anything that is past those fences is considered an outlier. If it's above the upper fence or below the lower fence, it's an outlier. And one final thing I want to remind you about on your whisker, this whisker does not go to the fence unless you have a piece of data on the fence. Think of a kitty cat going through the fence. It's electric fence. Don't let its whiskers touch the fence because you're going to fry the kitty cat. So don't let the whiskers touch the fence unless there happens to be a piece of data on the fence. Then it can touch the fence because it'll protect it. So the next piece of data inside the fence is where your whisker goes to. The next piece of data inside the fence is where your whisker goes to. All right. Moving on. Here we go. Okay, so this next page just has some information about normal, which we've been doing, hitting hard all semester, so we'll skip that. But do recall the 68, 95, 99.7 rule. Okay, let's go to this down here. We have not done a lot of these, so let's review this. This is a cumulative frequency curve, sometimes called an ogive. Okay, and of course, cumulative means what? You're accumulating the data. So I'm accumulate the number of pieces of data. Okay, Because think about it this way also. Let's think about this box plot. How much data is in each one of these sections, by the way? How much data is in each one of these sections? Good. There's 25% of the data in each one of these quartiles. Why is this bigger, more spread out? Is this because there's more data in there? No, it's because it's what? More varied, more spread out. So we can see here that this is going to give us an indication of the amounts of data and the collection of the counts of data. So for example, if we had, you could draw a box plot, you could put that on top of this. 25% of the data is there, and you could know where that goes to. And you could put your Q3 right here, and then you got your box, and then there's your median in this case. Could you figure out, if you knew what these values were over here to the left, could you figure out your fences, your outlier fences? Yes, you could. What is this distance here from Q1 to Q3? That's your IQR. So you could take that, multiply it by 1.5, and you could find an upper fence, and you could find a lower fence. So you could tell from a picture if you had upper or lower outliers. Okay? But over here to the left, I love, these pictures are so good and so rich in giving you a lot of information. These are histograms, and then they have superimposed on top of them the cumulative frequency plot. So look at the different shapes of the cumulative frequency plot. This is one that's going to be unimodal and symmetric. It's going to have most of the data here in the center, and so it's a steeper increase right here in the center, and then less data out on the edges, so it's less incline there. So look at this. Let's look at this one right here, this second one on the right-hand side. When you have a tall bar, you have more data in that bar. Do you agree with that? I have more counts of data. So this increase is faster because I am adding more data quickly, rapidly. I'm adding lots of data right there. But do you see over here in these bars, I'm adding small amounts of data. So the steepness of this curve and rate is less because I'm not adding as much data in those sections. So when you have a high curve, you are adding lots of data and you have a steep accumulation. This top left one is interesting because wouldn't you consider this almost uniform right here? Don't you think that looks fairly uniform? That uniformity is translating to a constant rate of increase. It kind of looks like it's a constant rate of increase. It almost looks linear right there, doesn't it? Because it gained the same amount for all of those bars. But then we trickle off and we gain just a little bitty bit, so these are then just real shallow increases here. You see how that works? So, in summary, oh, look at this one. This is a good one here. High bar, fast increase in accumulation. Smaller bars, it levels out to 100%. Okay, moving on. This page here is really just a page I had found that I thought was a good summary of concepts. I'm not going to go over with you. I've gone over a lot of those already. So that's just kind of a reference, another reference for you. And so now we're going to go to the songs. Okay, because there's some information in here that I do want to continue to give you. So we'll do that. So I want to kind of give you a couple of remind you of a couple calculator steps to help you. Now, on this problem here, we're on page 12. This is such a small data set that I don't think that it would be something where you would need to, put that in your calculator much and figure it out. I mean, to get the mean, sure. But it's not like you're getting the standard deviation of that. Standard deviation would be a really difficult formula that I would have told you. If you needed to do standard deviation, I would say go put that in list 1 and do one variable stats of list 1. And that would give you everything. Okay, so you could do that also. That will give you the 5-number summary, the mean, the median. S of X is the sample standard deviation, and sigma of x is the population standard deviation. Most cases we're using this sample standard deviation, by the way. But let's look at this second set of data, because this has 50 items, and I don't know about you, but I do not want to put 50 items in list 1. So this is about magazine subscriptions and households, and what it's saying is that 12 households have 0 magazine subscriptions, and 8 households had 1 magazine subscription, and so on. So you could go put 12 zeros in list 1, and then 8 ones, and then 17 twos, and 7 threes, and so on until you have 50 items in list 1. But I don't want to do that. So I'm going to put my values in list 1 and my frequencies in list 2. And I'm going to do one variable stats of list 1 with list 2's frequency. So if you have a menu on your calculator, then you're getting list 2 is in the frequency bar. If you have an older calculator that doesn't have the menu that pops up, then it would look like this. You would say one variable stats, and you would type in L1, comma, L2. If you do not put the comma L2, it will just average together what you have in list 1. Okay, so there's that. Now, be mindful to take out that L2 in the frequency spot and put it back to 1 when you are done. Because I have seen people calculate equations of lines, and then that messes up their equations of the lines. Okay, so make sure you put that frequency back to 1 or blank whenever you are done. All right, the next thing I wanted to talk to you about is this probability density function. This asks what's a valid, meaning a doable, probability density function. The key to that, so the important thing to look for this is a total area under the curve is 1. The total area under a normal curve is 1. The total area under a chi-squared curve is 1. The total area under a t-curve is 1. So these are shapes that you can calculate because they're triangles and rectangles and such. So you should calculate, actually mathematically calculate those areas and see if the area is 1. But be mindful, can you have negative probability? No, you cannot have negative probabilities. So in that case, look at this second triangle here. That's representing a negative probability, and you cannot have that, so that is not a possible valid probability density curve. Okay, so I think that is the main things that I wanted to go over with you. I wanted to remind you. See, here's one. Look, it's a transformation. You increase by 50. So do not go figure this data out. You just know, and don't go put 50, added 50 to every single one of those data. What do you know happens when you add 50? Think of, it'll change the what? Center only. Addition and subtract, addition and subtract, addition and subtract affects the center only, and so on. Okay, I think that's pretty much all I needed to tell you to make sure that you could felt good with your calculator, reminds you of those things. So, do pages 12 through 20. It's 23 multiple choice questions tonight for homework.